Hi, this is the fifth subtopic of chapter 1, functions, and the title of this subtopic is transformation of functions. At the end of this section, you will be able to graph functions by shifting them vertically and horizontally. You can graph functions by reflecting them across x and y axis. You can determine whether a function is odd, even, or neither, and you can graph function using compression and stretches. Also, you will be able to combine transformations. So, toolkit functions. We learned about toolkit functions. There are some functions that they are basic and we need to know them. It would be great if you know them, especially if you're taking calculus. Knowing these graphs by heart will help you to have a better view and understanding without spending time and creating a table and giving points to x and y. You need to know this is y is equal to x, or f of x is equal to x. This is f of x is equal to absolute value of x. In this video, we learn how to shift these graphs. For example, I know this is y is equal to x squared. So how does the graph of y is equal to x squared plus 2 look like? Or how does the graph of x plus 3 in parentheses square look like? Or in general, if I have the graph of f of x, then how is the graph of f of x plus k? So let's start with one example. Let's start with f of x is equal to x squared. If I give points to x and try to find f of x, then negative 2 squared is 4, negative 1 squared is 1, 0 and 0, 1 and 1, 2 and 4. And let's graph it. 0 and 0, 1 point, 1 and 1, 2 and 4, negative 2 and 4. So I'll graph. Now let's graph f of g. Let's call it g of x. G of x is equal to x squared plus 1. Then x and g of x. Negative 1 squared is 1 plus 1, 2, 0, 1, 1, 2, 2, 4 plus 1, 5. So negative 1 and 2 is right here. 0 and 1, 1 and 2, 2 and 5. So this graph is f of x is equal to x squared, and this one is g of x is equal to x squared plus 1. Now let's graph h of x is equal to x squared minus 1. So again, if I draw a table x and h of x and give point negative 1, 0, 1, 2, negative 1 square 1, 0, 0 minus 1 minus 1, 1, 2 square 4 minus 1, 3. So negative 1 and 0 here is 1 point. 0 and negative 1 is right here. 1 and 0 right here. 2 and 3 is right here. These graphs are not very exact, so and -2, 4 minus 1, again 3, -2 and 3. So if I graph it, I will have something similar to this, approximately. So this is x squared minus 1. You can see this was x squared, x plus 1. I shifted 1 unit up. And x squared minus 1, I shifted 1 unit down. So if I write it as fx plus k, if k is positive, I shift the graph 1 unit up. And if the k is negative, I shift the graph toward down k unit. So here we have in gx is equal to fx plus k, k is constant and is a vertical shift of f of x. All the outputs change by k units. If k is positive, graph will shift up, and if k is negative, graph will shift down. For example, I know this is y is equal to x. So if I want to graph y is equal to x plus 2, I just need to shift the graph 2 units up. That's y is equal to x plus 2. Or if I want to graph y is equal to x minus 3, I shift the graph, this one, 3 units down. -3. That's y is equal to x minus 3. So we had one example which was x squared, then x squared plus 1, then x squared minus 1, and we said we shift the graph up and down. Now what if we have a function like this, like g of x is equal to x plus 1 squared. There is a parenthesis and x and 1, x plus 1. You can see the difference between this one and this one. How does the graph look like in this situation? So again, let's graph x squared. I know the graph fx is equal to x squared is like this, 2 and 4, it's right here, 3 and 9 approximately. So this is f of x is equal to x squared. Now g of x, if I give points x, g of x, let's say 0, 1, 1, 1 plus 1, 2, 4, 2, 9, 2 plus 1, 9, -1, 0, -2, -2 plus 1, -1 and 1. Okay, so let's graph it. So 0 and 1, 1 and 4, 2 and 9, -1 and 0, -1 and 0, -2 and 1, -2 and 1. If I give another point, -3, -3 plus 1, -2 squared, 4, so -3 and 4. So this is, the green one is x plus 1 squared. You can see when I added a number inside parentheses, the graph shifted toward left 1 unit. So when it's positive, it's going toward left and it's inside the parentheses. And if I want to graph x minus 1 squared, and again I give point, h of x. So -2, -1, 0, 1, 2, -2, 9, -1 minus 1 squared is 4, 1, 0, 1, 3, 3 minus 1, 2, 4. And so -2 and 9, -1 and 4, 0 and 1, 1 and 0, 2 and 1, 3 and 4. And if I graph this, this is x minus 1 square. So when I x minus 1, I shift the graph toward right. So when it's inside parentheses, if I add one number, a positive number, I go toward left, and if I add a negative number, I go toward right. You can say, for example, x plus 2 square is, then x plus 2 square is 2 units to our left. 1, 2. X minus 2 square, this will be x plus 2 square, 2 units left. X minus 2 square, 2 units toward right. So it will be right here, 1, 2. You just transfer the graph toward right. So this is x minus 2 square. So I can formulate the outcome in this form. H of x is equal to f of x minus k. K is a constant. So for example, x plus 1 square, I know f of x is x squared, so I can write it is actually x minus 1 square. So k is negative. When k is negative, the graph will be shifted toward left. When k is positive, the graph is shifted toward right. Or for example, this one, x minus 2. So x minus 2, k square. K is positive, is 2. So 2 units to our right. You might be a little bit confused because here when we added a positive number, we moved toward left. And here we are saying, according to this equation, if k is positive, we move toward right. Because in the formula we consider a negative sign. So having function of f and g of x is equal to f of x minus h is constant, f is positive, we shift the graph to our right, and if h is negative, we shift the graph toward left. Having f of x, find the formula for g of x. So this is g of x, and I want to know the formula of this graph. F of x is x squared, something similar to this. So I can see that the graph was shifted toward right 2 units. So I use this equation, because when it's left and right, this equation. When it's up and down, then g of x would be fx plus k. left or right. So g of x is equal to x squared. So here we have x minus k. K is 2, is a positive number, minus 2. That's the equation. Given f of x is equal to square root x, graph original function of f of x and transformation g of x. Is it horizontal or vertical shift? So it's fx plus minus k. Fx plus 2. If you compare it with our equation, fx minus k, so it's left and right is horizontal shift. Which way is it shifted? Is it shifted toward right or left? How many units? 2 units. So we have negative here, so we need to write this one is actually equal to fx minus 2. So k is negative 2. So the graph is shifted 2 units toward left. So here is square root of x and square root of x, and this one is square root of x plus 2. Given f of x, sketch h of x. So f of x is equal to absolute value of x. F of x plus 1 is equal to absolute value of x plus 1. So 1 is inside the absolute value, so we need to move left and right, not up and down. Fx minus k, then k is equal to negative 1, so we move 1 unit to our left. You can write this as x minus 1, so k is negative 1, so 1 unit to our left first. So here is absolute value of x, and this one is absolute value of x plus 1. 1 unit shift to our left. Then minus 3, then absolute value of x plus 1 plus k, fx plus k minus 3. So now we go up and down. 3 units down. 1, 2, 3. So negative 3. So this is absolute value of x plus 1 minus 3. As you can see here, this is absolute value of x. This is plus 1, shift toward left, and this is minus 3, shift toward down. Given f of x, absolute value of x, sketch the graph of h of x. So here, absolute value of x. F of x minus 2 means absolute value of x minus 2. So k is positive, fx minus k. K is positive, so 2 units. This will move to our right. So 1, 2. This will come right here. And this will be, so this is absolute value of x minus 2. 2 units shifting to our right. Plus 4. So fx plus k. K is positive, so 4 units going up. 1, 2, 3, 4. and this is absolute value of x minus 2 plus 4. Write a formula for the graph which is transformation of square root function. So this was transformed. The original function was square root x. So it was 1 unit shifted to our right, 1 unit right, 1 to 2 units up. So 1 unit to our right, that means x minus 1, 2 units up plus 2. That's the equation of this graph. Write a formula for transformation f of x is equal to 1 over x that shifts function 1 unit to our right and 1 unit up. So to our right is fx minus k, and to our up fx plus k. If I want to mix both, then it will be fx minus 1 unit to our right, so minus 1, and 1 unit to our up, and that would be 1 over x minus 1 plus 1. So this is the new formula. Graphing functions using reflections. So if g of x is negative f of x, then it's vertical reflection or reflection across x-axis. And if g of x is equal to f of minus x, then it's horizontal reflection or reflection across y-axis. For example, let's say f of x is equal to square root of x. We know the graph of a square root of x is like this. Now, if I want to find negative f of x, that means g of x is equal to negative square root of x. And if I give points x, g of x, 0, 0, 1, minus 1, 4, negative 2, and I graph it 0 and 0, 1 and negative 1, 4 and negative 2. So this is negative square root of x, and this was square root of x. It was reflected across x-axis. Also we call it vertical reflection. It was vertically reflected. If I want to find f of minus x, so that means square root of negative x, then if I give points x and g of x, I cannot give negative numbers, so 0, I cannot give positive numbers, so 0, negative 1 and negative 4, 0 and 0, negative 1 and 1, negative 4 and 2. So 0 and 0, 1 point, negative 1 and 1, negative 4 and 2. So in this case, it was reflected across y-axis, or we say it was reflected horizontally. This is a good example to remember these rules. So you know this is square root of x, you know this is negative square root of x, and this is square root of negative x. This is f of x, this is negative f of x, and this would be f of negative x. So negative f of x was reflected across x-axis or vertically, and f of negative x is reflection across y-axis. Reflect the graph f of x, absolute value of x minus 1, vertically and horizontally. So let's graph absolute value of x first. So this is absolute value of x. We want to graph x minus 1, absolute value of x minus 1. So we need to shift this 1 unit toward right. So this is 1. This is absolute value of x minus 1. Now we want to reflect it vertically. So it would be like this. So this is minus absolute value of x minus 1. And horizontally, if I want to, it will be same as x minus 1. And this is absolute value of minus x minus 1, which is equal to absolute value of x minus 1. Using table to find reflections. So here we have x and f of x. We want to find g of x and h of x. G of x is negative f of x, means reflection across x-axis. H of x is f of negative x, means reflection across y-axis. You can think of the example we had. This is the square root of x. Let's say f of x is equal to square root of x. This is g of x is equal to minus fx is equal to minus square root of x, and this one is h of x is equal to f of minus x is equal to square root of minus x. So if I want to draw data for x and g of x, you see inputs didn't change. When the reflection across x-axis, x variable didn't change, y variable became negative. So again, 2, 4, 6, 8. Here we put negative for g of x. Negative 1, negative 3, negative 7, negative 11. And if I want to draw the table for h of x, y variable didn't change. When the shape was when the graph was reflected across y-axis outputs, y variable didn't change. So we just write y variable 1, 3, 7, 11. X variable changed, became negative, positive, negative. So here 2, 4, 6, 8, negative 4, 2, negative 4, negative 6, negative 8. So in g of x is equal to negative f of x. X doesn't change. G of x, the outputs change sign. And in h of x is equal to f of negative x, x variables change sign. For example, a function f of x is given and we want to draw a table for g of x and h of x. g of x is negative f of x. So here the table. G of x is negative f of x, so negative 5, negative 10, negative 15, negative 20. X doesn't change. 2, 4. H of x is f of minus x, so another table for h of x. Minus x, minus 2 is 2, 0, minus 2, minus 4, and we put the numbers 5, 10, 15, 20. So here we have a graph of f of t. F of t is equal to 2 to t, and we want to graph k of t. So f of t is 2 to t. Now we want to build this part, 2 to negative t. This is f of negative t, 2 to negative t, and its reflection across y-axis. So t changes sign. Now they are negative 5, 4, 2, 1, so they will be 5, 4, 2, 3, 1. Almost. So this is 2 to negative t reflected across y-axis. Then minus f minus t is equal to minus 2 to negative t. Reflection across t-axis. So t doesn't change, but y changes. So this one is minus 2 to minus t. Plus 1. 1 unit we shifted up. So we go 1 unit shifted up. This is minus 2 to minus t plus 1. So here is the solution. This is 2 to negative t. So 2 to t was like this. T changed sign, became negative. So here they are original graph, negative 3 to 1. Here, t here is 3 to 1. Then negative 2 to negative t, reflection across x-axis, because minus f minus t. Output changes sign, and plus 1, shifting 1 unit up. Given f of x is equal to x squared, graph g of x is equal to negative f of x, and h of x is f of minus x. So we know this is f of x is equal to x squared. G of x is negative f of x, so that's a reflection. That means x is not changing, outputs are changing, so it will be like this. This is minus x squared, reflection across x-axis. And f of minus x, that means output is not changing, x is changing. If x changes, reflection across y, the new graph also will be same as the original graph, because it's symmetric across y-axis. Then when you reflect it, it is same. So this one is the green one is minus x squared, which is equal to x squared. These graphs that are symmetric across y-axis, like y is equal to x squared, or absolute value of x, these are called even functions. So even functions are symmetric about y-axis. F of x is equal to f of minus x. And if the graph is symmetric across origin, it's called odd function. Example, f of x is equal to x, f of x is equal to x to the third, and this one is f of x is equal to sine x. These are examples of odd functions. So in odd function, f of x is equal to negative f of negative x, odd. But for even, f of x is equal to f of negative x. So if f of x is equal to f of minus x, then it's even. If f of x is equal to minus f of minus x, then it's odd. And if none of this is true, then it's not even nor odd. The function f of x, even, odd, or neither. So f of x is equal to x to the third plus 2x. We say that if f of x is equal to f of negative x, then it's even. For example, x squared is equal to negative x squared, so it's even. And we said if f of x is equal to negative f of negative x, then it's odd. For example, x to the third is equal to negative negative x to the third, so it's odd. So the step 1 is finding f of negative x is equal to negative x to the third plus 2 times negative x, and that's equal to negative x to the third minus 2x, factoring a negative, x to the third plus 2x. So this is f of x. We can see that f of negative x is negative f of x. That means f of x is equal to negative f of minus x, which is this one. So it is odd. Is the function f of x is equal to 3x squared plus absolute value of x even, odd, or neither? So again, f of negative x is equal to 3 negative x squared plus absolute value of x, and that's equal to 3x squared plus absolute value of x. So f of negative x is equal to f of x, so the function is even. Is the function even, odd, or neither? So f of negative s is equal to negative s to the fourth plus 3 negative s squared plus 7, and that's equal to s to the fourth plus 3s squared plus 7. So f of negative s is equal to f of s, again it's even.